So what we want to look at in this segment is forces on inclined planes. So let's draw an inclined plane. Our inclined plane has some angle theta, and then what we want to do is we want to set some block on our inclined plane and think about how our block interacts with gravity and the plane that it's in contact with. So the one thing we know about gravity always works straight down, and the normal force always works perpendicular to the surface that the two objects are in contact with. So in this case, there's the normal forces here, and gravity is pulling straight down. So what this turns out is you can imagine that gravity is made up of some triangle here. So let me explode that triangle. And that gravity has a component here that's parallel to the plane. So this is like, and this is our angle theta. And this theta here is the same as that theta here due to the law of similar triangles. And so when we have G here, this part here then becomes, this is our right angle, this is G cosine theta, and this is G sine theta. And you can see when we're looking at this that G sine theta is down the ramp. This G sine theta is parallel to the ramp. And G cosine theta is in the direction of the normal force. And so the general strategy then, when you're working on an inclined plane, is to draw your coordinate axis now so that your x-axis is parallel to the plane. So we'll draw our coordinate axis, coordinate axis. So the x is parallel with the plane, and the y is perpendicular. Should have just drawn the symbol. So y is going to now be in the direction of the normal, and x is the one that's parallel to the plane. So when we look to sum our forces on the system, what do we get? So now when we look at the sum of the forces in the y, those equal MAY, but we're going to look at our rotated axes, and the sum of the forces now in the y, our new y direction, the sum of the forces in the y then would be the normal force, and it's pointing up, but this time it's minus G cosine, minus mg cosine theta. And that has to equal MAY. But as usual, since our object isn't moving up in the direction of the normal or going through the plane, we say that AY is equal to 0. So that tells us that N minus mg cosine theta equals 0. Or the normal force is equal to mg cosine theta on an inclined plane. Now what's happening in the direction parallel to the plane? Well, when we look at the sum of the forces there, when we sum the forces there, the sum of the forces in the x is MAX. But parallel to the plane, there's only one force acting. And that's going to turn out to be mg sine theta. And since that's in the negative axis, negative mg sine theta equals MAX. And so AX is minus G sine theta. And so the object is pulling it, in this case, it's pulling it in the negative x direction, and that would give this G, that would give our acceleration a negative value. If you drew your inclined plane the other way, it just turns. So if we turn around and draw our inclined plane this way, now we still rotate our axis. Everything works out the same, except this time, under this condition, AX would then be G sine theta, and you get some positive value because you're accelerating in the positive X direction. So it turns out that we can now work problems on an inclined plane. So what we do is we make sure that we rotate our axis, we draw our coordinate axis, so X is parallel to the plane and Y is perpendicular. We make sure that we break gravity into its components, so it then will, with our rotated frame, G cosine theta will then be in the Y, and G sine theta is parallel to the plane, so that puts it in the X. Then we go about doing what we normally do. We sum our forces in the Y to analyze the normal, and we summed our forces in the X to look for any accelerations in the parallel to the plane of the incline.